We're going to take a few minutes here to do a recap of some of the code that we saw in the data carpentry Unix shell workshop for genomics. If you haven't done the workshop for genomics, it's really good. Head on over to the data carpentry website and you can check that out. And hopefully go and learn something. It's a great place to start out if you know a little bit about next-gen sequencing or genomics, genomic data, and are hoping to get your feet wet in bioinformatics for something that you're planning to do. We use this in my classes as an introduction to the command line, and if you're watching it after that, we're going to check out some of the work that we did in the class in a condensed version, so we can revisit some of these ideas. All right, you're going to want to head on over to your favorite access point to the Unix shell. We like using RStudio because it's going to give us access to a terminal here on a Unix system where we're running this. So we're going to have access to the shell right here, and we're going to be able to work interactively through some of this code that we want to play with here. All right, so we saw in the Unix shell workshop a bunch of different commands that let us move around in our file system, view files, learn about those files, view them, count lines, search for character strings, all kinds of things. So we're going to put that to work here. We're going to do a little bit of exploration of our file system and take a look at some of these files that we have from the workshop. All right, so the first thing we're going to do is an ls. And I'm in the folder where I set up earlier the shell genomics web materials. So I'm going to cd into shell genomics and check out what's here. All right, earlier we were working in the shell data folder. So I'm going to cd into shell data. If you go deeper into the genomics workshop, there's a bunch of other data. That's what these other files are. Right, so shell data and then ls. Mostly we were working in untrimmed FASTQ and ls again. All right, and actually there's some extra stuff here. So I'm going to say ls-f just to make sure. Yep, we got a folder called backup and then a bunch of text files that come after that. So a handful of FASTQ files and one text output there. Okay. All right, so CD to move into or out of directories, ls to see what's there. We can also CD back one directory with the code, the shorthand CD dot dot. That's going to go from untrimmed FASTQ back up to shell data. All right, CD untrimmed. All right. We can check out where we are in our file system with the command pwd. This is a little bit of an unconventional path here, but that's the full path to where we are right now, which can be handy to know. You might want to take notes down where you are when you type pwd with these data so that you can find your way back to those later. All right. We can also use ls to look for specific files. So I'm going to say ls srr asterisk, and that's going to search for anything in this folder that starts with the letters srr, and the asterisk represents anything after those characters. So that's what we call a wildcard. It can be one or more of any other character, and it will find us all the matches. So if we do that, we get 3 srr files. We're going to mostly want to work with, let's say this one, say cat srr 098026.fastq. All right, so here's our next command that we're going to be running. Cat is going to show us the contents of this file. A word of warning, this works with this FASTQ file because it's relatively small, but if you know you're working with larger data files, cat may not be your best option here. So we're going to take a look in a second at one of those. So we run cat, and it prints out a whole bunch of FASTQ data, and like there's a lot of it, right? We can scroll up through that, and maybe that's not all that helpful. So I'm going to clear that out. Control L, by the way, clears your terminal and brings a nice clean prompt back up to the top. All right, so cat showed us way too much. Let's take a look instead at just the first part of this file with the command head. So head is going to print just the first 10 lines. And there we go. So head gives us a pretty good view. We can ask for a specific number of lines by modifying head with a dash and the number of lines we want to see. So I want to see the first 12 lines. Aha, there we go. All right, so now we get a pretty good look at the structure of our FASTQ file. This is going to be important for all of you going into our genomics analyses. Each FASTQ data entry, each sequence has 4 lines of data. The first one has information about the sequence read. We don't need to worry too much about that yet, but they have an ID number, which is the same, that SRR number, and then .1, .2, .3, on down. There's some information about how it was sequenced and what we've got here. And the length is given in the last parameter on that line. The next line is the actual DNA sequence, which here looks a little funny because we've got a bunch of ins in this sequence. Ins are an ambiguous character. So the only valid character we have here is the cytosine right in the middle for this sequence. The third line in FASTQ can be structured this way, where it repeats that metadata about the sequence, or it can just simply be a plus with nothing else. Both are equally okay in FASTQ. And then the fourth line and the last line for this entry is the string of quality scores. Quality scores are represented in FASTQ with a series of symbols. And we don't need to know what those are just yet, just that that's quality scores. So we've got information, DNA sequence, a spacer, or more information, and quality scores for each nucleotide in the read. All right, and then that continues on, right? We've got 4 entries for every sequence on down to the bottom. All right, and head's handy because it just gave us a little bit of data. We can see enough of it to get a feel for what we've got in this file, but not so much that it totally fills up our terminal. Another handy command on the command line for viewing just part of a file is less. All right, less is going to do the same thing as head, but it's interactive. So it opens up this kind of prompt here that lets us scroll through our FASTQ file. We could scroll to the bottom. We could just keep scrolling and scrolling, but we don't need to. If we're satisfied with what we've seen, that everything looks to be in order, we can just type Q and get out of here. Less is nice because it lets you scroll through the file, but it doesn't change anything about the file. It's not an editor, it's just a viewer. So it's a handy way to take a peek at large files that you only have access to through the shell. All right. So we might want to do some manipulation of our data. We might want to move things around, make copies. So let's take a look at a potential workflow to create a backup directory and copy a version of our file into that backup directory. So first we're going to do mkdir back or backup. Actually, I already have a backup, so I'm just going to call it back, make dir back. That's going to create a new folder called back, which we've got over here. And then I'm going to use the cp command, copy, to copy that SRR file that we've been working with into back into the folder back. So we don't have to name that. We're going to do this in 2 steps. So we copy that file into back. Now nothing has changed here, so let's CD into back and see what we've done. All right, now we're in back and we type ls, and now we just have that one file. So we've made a copy of it. Maybe we want to work on this file. Maybe we want to keep this as the original version so we can't mess it up. Either way. All right, so we've copied that. Now we might want to rename this file so that we know that it's different from the one we had before. All right, so to rename something or to move things around in the file system, we're going to use the command mv, which stands for move. Move just changes the pointers to where the file data are actually stored on your disk. So it's an efficient way to move things around because it's just changing the pointers in the file system. That also means it's a convenient way to rename your files. So we're going to rename our SRR file to the same name -backup.fastq. All right, and note that we don't have 2 files in here now. We still only have 1, but it's now called srr-backup.fastq. Okay, so we've been CDing around our file system using ls to view files and find what we're working with. Now we're going to go into working with files and searching through files and then pairing up different processes through redirection and pipes. So with our data, if we do ahead of this backup file, with our data, you might notice there's a whole lot of ins in the DNA sequence. That may be a sign that we have not the greatest data in this file, but we don't know to what extent we've got this. So we might, if you're handed some genomic data, you might want to find out about that data before you start into analyses, only to find out that they're not working. So we can take another shell tool called Grep and use it to search for a character string. So I'm going to search for, let's say, 9 ins in a row in our SRR file. And Grep is going to read through that file, and it's going to return only the lines where we have 9 ins or more in a row and print those back to the screen. So let's run that and see what happens. Okay, there we go. So print it out. It spit out a whole bunch of ins, some with more good sequence, some with less good sequence. On down, right? So as we scroll down, we get more A's, C's, G's, and T's, and somewhat fewer N's. But there we are. So we found that. It looks like it's pretty extensive. So we might want to know more about these data. What sequences are these? We might want to learn more about that. So we can use Grep again to give us the full context of the FASTQ data entry with 2 flags. -B1 says, when you find a match, go back 1 line, go up 1 line. So the match is on the 2nd line of the FASTQ entry. Going up 1 line is going to get the metadata line. And then -A, capital A, 2. So after you find that match, read the next 2 lines, the spacer line and the quality score line. So it's going to read 4 total lines, the match -1 and +2, and it's going to return the whole FASTQ entry to us. All right, when we run that, we see something that looks like FASTQ data, 4 lines at a time, giving us the matches and then the metadata and quality around those. You might notice that where we have a lot of ins, in the DNA sequence. We also have a lot of these exclamation points in the quality score sequence. We'll talk later about how to read these quality scores and what they mean, but suffice it to say, the exclamation point is not a good sign. All right, that's pretty good. So we found our way to outputting the, maybe the hypothetically bad reads from this data to the screen. We might want to save those so that we can come back to them in our project and find out more about those. So we can do that with redirection, which works for any Unix command that prints something to the terminal. We can redirect it with the greater than sign to a file name. I'm going to call it badreads.txt. You can call it anything you want to here. And notice that time grep didn't print anything to the screen because all of that output was captured by the redirect and sent to the file. So let's see if that's right. ls created a file called badreads.txt, and then head badreads shows us that we put some data into that file. Cool. So now we might be curious if we have been handed these data, how many of our reads were bad, and we can get a quick peek at that with the command WC. WC counts lines, counts characters, and counts words. WC stands for word count. We're going to use it with the -L flag just to count the lines, which is honestly about the only way that I use that. And we're going to do bad reads as the input file to WC. We're going to run that, and we get 892 matches with the way that we formulated the grep in this demo. So 892 sequences with 9 or more consecutive in characters in a sequence read. All right. Last but not least, we can put these ideas together. We can go back up to our grep command, and instead of redirecting these to bad reads, if the only thing we wanted to know is how many matches we have, we can use the pipe symbol, so shift / to get this straight up and down line. And we could just pipe this output directly to another tool. So let's do it first just to less, so we can take a look at the output. So we pipe it to less, and we can scroll through. We can take a look at the sequences that have that match. And if we want to know exactly how many we need or we found, we can pipe it to WC and -L. And then we don't have to put in a file name because we're not inputting a file here. We're inputting the stream from the pipe to capture the output of grep. So it's similar to a redirect, but pipes go to another program, not to a file. So let's run that. And that time it just prints 892. Beautiful. So we count the number of matches and output that to WC, and then WC counts the number of lines that were found by grep. Okay. And that's going to be it for this demo. There's a lot more in the Data Carpentry Shell workshop. You should go over and check that out. The good folks at Data Carpentry have done a nice job setting up those pages, and there's a lot of useful information in those. But that's it for our quick recap tonight.